Megnapari, and today we are here to start the lecture series of Mathematics-02. Chapter is Vector Calculus and it's lecture 7, Application of Line Integral. Application of line integral, that means work done and circulation. Work done by a force if vector field F bar is a force acting on a particles moving along the arc AB of the curve C, then line integral of A to B F bar into dr bar represent the work done in the displacing the particles from the point A to B. Again, if vector field F bar is a force acting particle moving along arc AB, the curve C, then line integration A to B F bar into dr bar represent the work done in displacing the particle from point A to B. Circulation. If vector field F bar is velocity of fluid particle, so C is closed curve, then the line integral over closed contour F bar into dr bar represent the circulation of the F bar around the curve C. Flux. If vector field F bar equal to P of xy I caret plus Q of xy j caret is some kind of fluid flow and C is the curve, then the line integral over C F bar into n caret ds represent the flux of F bar through the curve C, where n caret is unit normal vector. R bar is position vector on the curve C, so we take R bar equal to xi caret plus yj caret, dr bar equal to dxi plus dyj. T caret is unit tangent vector to C, so dr bar equal to t caret ds, t caret ds is dxi dyj caret. The unit normal vector n caret is perpendicular to t caret, then n caret is obtained from the rotating t caret through the pi by 2 clockwise direction. So we get n caret ds equal to dyi minus dxa caret. So what is our flux? Flux formula is integration over C F bar into n caret ds. N caret ds is dy I caret minus dx j caret. And what is F bar? F bar is pi caret plus qj caret. Multiplication of these two brackets, we get p dy minus q dx. Example 1. Find the work done when the force F bar equal to x square minus y square plus 2x minus 2xy plus y. Moves a particle xy plane 0, 0 to 1, A to B along the parabola is y square x. Is the work done different when the path is straight line y equal to x? So we have to find the work done for the parabola curve y square equal to x, and also check the condition is the work done is different if we are taking a path of the straight line y equal to x. So we take first the parabola y square equal to x. Parametric representation is for the parabola is y equal to t and x equal to t square. This is our equation 1. What is initial and boundary point? It is 0, 0 to 1, 1 and t between 0 to 1. Now the work done along the parabola f bar dr over c. What is this? This f bar x square minus y square plus 2x minus 2xy plus yj caret. Dr is dxi caret dyj caret. Multiplying these two brackets, we get x square minus y square plus 2x dx minus 2xy plus y dy. Now we have x equal to t and y equal to t square. Y equal to t and x equal to t square. Put this value in this case. We are getting a whole integration in the t formation. To solve this t polynomial of this t, we get the equation 2t raised to 5 minus t dt. Integrate this with respect to t, we get minus 1 by 6 of the work done through the parabola curve. Now for now first we check the straight line y equal to x. For the straight line y equal to x, parametric equation is x equal to t and y equal to t, and initial point is 0, boundary is 1, variation t is 0 to 1. Now work done of the straight line. Integration c over c f bar into dr x square minus y square plus 2x I minus 2x plus y into dxi plus dyj. Multiplication of these two brackets, we get x square minus y square plus 2x plus 2xy plus y minus plus minus. Now put the value equal x equal to t and y equal to t. Whole integration is converted into t formation. Now integrate this function with respect to t. It is t square by 2 minus 2t cube by 3, 0 to 1. Upper limit minus lower limit, answer is minus 1 by 6, which is the same as a 1. So f bar into dr equal to 1 minus 1 by 6. Work done is remains same along the both the path. Okay. Second example, find the work done. Y minus x square minus z minus y square j plus x minus z square k over the curve ti caret t square j caret t cube k caret, and t is 0 to 1. What is our boundary? It's 0 to 1. Now work done is f bar dr. We take the function f bar y minus x square dx z minus y square dy x minus z square dz. Why? Because we are taking here y minus x square I caret minus z minus y square j caret plus x minus z square k caret into dxi caret dyj caret and dz plus dz k caret. To multiply this bracket, we get simple form of integration. Now, from this, we have x equal to t, y equal to t square, and z equal to t cube. Put these all value in the equation. Y equal to t square, x equal to t, z equal to t cube, y equal to t square, x equal to t, z equal to t cube. What is dz? dz is 3t square. What is dy? dy is 2t dt. What is dx? dx is dt. Whole equation is converting to t formation. To solve this t polynomial, we get this formation and integrate this. Put the value of upper limit minus lower limit, we get answer as 29 by 60. Third example, find the work done by the conservative field along smooth curve C joining A minus 139 to B 16 minus 4. Work done is f bar into dr, A to B, this is the curl of f, into dr bar, f of B minus f of A. What is f of B? f of B is xyz square. This is the form 16 minus 4 minus xyz square minus 139. Answer is 339. The line integral formula of the f of b minus r of b minus r of a. Find the flux f bar equal to 3xy I caret minus xy j caret through the parabolic arc y equal to x square between minus 1 to 1 and 4 to 16. Now formula of the flux is integration over c f bar n caret ds. F bar is pi caret qj caret. N caret ds is dyi caret minus dxj caret. So multiply this bracket, we get integration a to b pdy minus qdx. Pdy minus qdx is 3xy dx dy. We are differentiate with respect to this, so it's p, it's your q. 3xy dy minus xy dx. Now path is y equal to x square, so dy equal to 2x dx, and for the x is minus 1 to 4, taking flux minus 1 to 4, 3x. For y, it is 3x, it is y. For y, we are taking x square. For dy, we are taking 2x dx minus x minus y equal to x square dx. Whole equation is converted to x formation. Solve this x formation and integrate this. We get 6x raised to 5 upon 5 minus x square by 2 plus x cube by 3, 1 to 4. Put upper limit minus lower limit, minus 1 to 4. Put upper limit minus lower limit. We get the answer as 7465 upon 6. There is a application of the line integral to find the work done and flux. Thank you.